Assalamu alaikum. This is lab 17, which is about the implementation of traversal methods for binary search tree. We have discussed them thoroughly in the question answer in the online sessions. What is tree traversal and what are its three variations: the in-order traversal, the pre-order traversal, and the post-order traversal. The video link to that online session is also given, so that you can refer to that in case you have any problems. We would discuss only the implementation details here. So quickly, what is an in-order traversal? For example, if this is the given binary search tree, then in-order traversal method suggests that before visiting a node, we go to its left child. Then after visiting its left child or left subtree, we come back to the node, visit it, and then we move to its right subtree or right child. For example, in this case, A is the root, so we start from A. We don't print A or we don't visit A. We go to its left child, which is B. We go to the left child of B, which is D. We go to the left child of D, which is H, and its left child is null, so we print H. Then we come back to D and we print this, and then we go to the right child of D, which is I. So we visit it and we go back to the parent of D, which was B. We visit it and then we go to E, and but before printing E, we go to its left child J. So we first print J, then we come back to E, and then its right child is null, so we go back to A. We print A and then we come to C. We don't print C yet. We go to its left child F, and then come back to C, and then G. So the in-order traversal method would give, if we print every node's character, so it will give H, D, I, B, J, E, A, F, C, and G. Okay, so this is the in order, and then the pre-order is actually pretty much same, just that in pre-order we first visit the node, and then we go to it, traverse its left subtree, and after that we traverse its right subtree. So for example, the pre-order would give the string A, B, D, H, I, E, J, and so on and so forth. So we would this has been thoroughly discussed in the class, so no need to go into the details of this. These are the algorithms. For example, in order traversal, you call the method itself recursively to traverse the left subtree, then you visit the node. After you encounter a null in the left subtree, you visit the node, and then you call it this method recursively to traverse the right subtree. Similarly, the pre-order traversal, the order is visit the node first, then its left subtree, then its right subtree. And for a post-order traversal, you first visit the left subtree, then right subtree, and then visit the node. So we the implementation, the recursive implementation, is pretty much straightforward and simple. The way this recursion works, which we discussed in the class, is important to understand. Okay, so we would continue to implement these methods in the same class that we previously defined for the previous lab, where we implemented the insert and search methods of binary search tree. So for example, here this search method ends, so we define this in order traversal. I would call it in order, or in order, and R to represent recursive implementation of this in order. So this method won't return anything, and its name is in order REC, let's suppose, recursion, and we pass it a node to start with, which would be the root node of the binary search tree that you defined in the previous lab. Okay, so first of all, what we do, we check that if this node that we pass to this method, if this does not refer to null, if it is not equal to null, then what we do, remember it's in order. So in order is first you have to visit the left subtree. So for the left subtree we call this method again, and we pass it not the local root but the left child of this local root node. Okay, then once you have visited the left subtree, what we do is we print this local roots value data. Okay, and let's suppose I just insert a space so that the next value is printed after a space. Okay, and after that we call this method again, and this time we pass it local root dot write. Okay, so just this method would print the or traverse the binary search tree in order, but remember that this is the recursive implementation. So for pre-order and post-order, actually this method would be just the same, except for the order in which we would visit the nodes. So let's suppose this is pre-order, so pre-order recursively. Here also we need to change this pre-order recursively and pre-order recursively, but this time you access the node first and then you go to its left subtree, and after that you go to its right subtree. Okay, and then finally, okay, the post order traversal. So the post order traversal, you just need to change the order in which you visit a node. So in this case the node is visited last. First its left subtree, then its right subtree, and finally the node itself. Okay, like this. So let's run this and see what happens. Okay, we need to call these methods here. So first of all I print it in order. After that I print it, let's suppose I print a new line, and then I call the pre-order and I pass it the root of the BST, and then I call the post order and I pass it the root of the tree. So let's see how do they work. So you see, for this given tree, okay, the pre-order we have from 50 we go to its left child 30, and from 30 we go to the left child 20. We print that 20, we come back to 30, we print the 30, and we go to the right child, which is 40, and after that we go to the parent of 30, which is 50, and we print that, and then we come to its right child, which is 70, but we don't print 70. We go to the left child of 70, which is 60. 60 is a leaf node, so we come back to 70, we print the 70, and we go to its right child 80, and after the 80 is printed, the binary BST has been fully traversed in order. Okay, you must notice that the in order traversal of a BST gives the data in data items or data elements in the BST in ascending order. Okay, 20, 30, 40, 50, 60, 70, 80. But the pre-order, we visit the node first, so 50 is printed first, then we go to 30, it's printed first, then we go to 20, it's printed first, and then we go to after the left child we go to 40, the right child of 30, and then we go back to parent and we go to its right child, which is 70, and 70 is printed first. After 40, 70 is printed, and then 60 is printed, and then 80 is printed. And the post order one, in the post order we first print the left child. So from 50 we go to 30, and from 30 we go to 20. We print 20, and then we go to the right child of 30, which is 40. We print that, and then we print 30, and after that we after printing this the left subtree of 50, we have to print the we have to traverse the right subtree of 50, which is the right child is of 50 is 70, but we don't visit 70. We first print its left, which is 60. So we print 60, then right 80, and then we go back to 70. We print that, and then we go back to 50 and we print that. So you saw that recursive implementation is very simple and straightforward in terms of coding, or in terms of in terms of its implementation, but it's important to understand its working, how recursion works, how the stack is used by the compiler to retain the node that is being pointed by a local root pointer, and also the returning addresses, which we covered very thoroughly in the question answer sessions. So I recommend you to implement these methods yourself, and then for your lab task you have to implement these methods without using recursion. Like, you don't have to call these methods recursively as we have been calling these methods here, but instead you have to think how you would be using the stack for this. So here is the stack class which I have which we have implemented already, and I just changed it to a generic type, so that you can in your program or in your method, let's suppose I just give you some hints. For example, if this is the method public static void in order non-recursively, okay, and you pass it the root, let's call it whatever node root, okay, and then what you do is basically the following. For this you would, so first of all you check if this root that you passed is null, so it means the tree is empty. If root is equal to null, then you just return from this method. Otherwise what you do is you have to traverse the tree. So for that you need a temporary node pointer which we call current, let's suppose, okay, and then what you would do is you would need a stack. So I declare a stack variable of type node, okay, and I call it recursive stack or whatever, because it has to store the values for recursion, is equal to new stack of type node, okay. What's the problem here? Okay, I don't have a constructor here, so let me implement that. Okay, so I just gave the size for the stack, which is just arbitrary for now. Okay, so now we have a stack to store pointers. Now we have to traverse the tree. So remember, it's in order traversal. So what we do is we use a while current is not equal to null. So what we do is the following: we have to move to the right of okay, node current must be initialized, so let's call it initialize it with root. So while current is not equal to null, what you do is you have to move to the right to the left child of the current. Okay, current is equal to current dot left, but before that what you do is you push this current to the recursive stack that you just declare, and it must have a push of type node, so you put this you push this current onto the stack. Okay, and this loop will take you to the leftmost child of the tree. So once you encounter that the null in the left subtree of the root node, so what you do is you first what you do is you pop from this stack. Okay, and then so you pop, and you this pop will return you a node pointer. So I update this current with this last inserted reference on the stack. So now current is pointing to the last leaf node, leftmost leaf node of the tree. So I just print its value. Current.data, and then I call this after printing the data, I have to traverse the right subtree of this current. So I just update this current with current is equal to current dot right. Okay, since this is in the while loop, where is the while loop? Yeah, so okay, this current this whole block should be in another while loop after declaration of the stack. So I check that while current is not equal to null, or this recursive stack is not empty. Okay, so this if both of these conditions are true, then this whole block will run repeatedly, and this method will basically do the same work that this in order recursive was doing using recursion. Now here the recursion is not used because you are not calling this in order method again inside of itself, but you are doing the you are pushing the pointers on the stack yourself. You declared explicitly a stack to store the pointers, and you are pushing the pointer to the current node onto the stack, and then you move the current to the left or right accordingly, and this will give you an in order traversal of the tree non-recursively. So first you have to implement this yourself, run it and check if it's working properly, and then update the pre-order and post-order non-recursive methods as well. Thank you very much.